Hello everyone, my name is Harish Chandra and today I'll be presenting my capstone project titled DeepCSAT, e-commerce customer satisfaction score prediction using deep learning. So customer satisfaction or CSAT is one of the most important matrices in e-commerce sector. A single negative experience can make a customer abandon the platform, while a positive experience increases loyalty and chances of repeat purchases. And traditionally, companies have measured CSAT through the past purchase surveys, but those surveys are limited. Not every customer responds, and responses are delayed. Also, it can't capture the full customer journey. So, the challenge we set to solve was, can we predict the customer satisfaction score automatically using the rich data generated during their interaction with the platform? So let's look out at the benefits of this project. So the benefits are huge. Here is the list of few. The businesses can act in real time to rescue the at-risk customers. Managers can identify patterns across agents, shifts, or product categories that affect satisfaction scores. Next, it creates a scalable proactive alternative to traditional surveys. Now, in this project, I built a complete solution. First, a data pre-processing pipeline and feature engineering pipeline. Next, we have the second, which is an artificial neural network to predict the CSAT score. Third, a deployment-ready app built in Streamlit. By end of this video, you will see how the project can directly translate into real-world implements in customer service. So we move ahead and let me give you the dataset overview used for this analysis. So the dataset was actually provided as a part of this project and represents 1 month of the customer interaction data on the platform called ShopZilla. Let's break down the key features. So in the key feature list, we have the first service related fields, which are like channel of communication, inbound, outbound, or it could be email. Then we have the category and the subcategory of the interaction. Next, with respect to customer remarks, we have an open text feedback provided by the customer. This is an unstructured field that often contains sentiment signals. That's why we can't ignore it. Next, we have the product and order related details, wherein we have the order IDs, order timestamp, survey date, product categories, and the item price. Then we have the operational data, such as the connected handling time, timestamp of when an issue was reported, and when it was responded to. Then we have the customer agent who was involved in this case. We have the customer agent name, supervisor and manager name. Then we have tenure bucket and the shift timing. And finally, as the target variable, we have the CSAT score, which is an integer representing the customer satisfaction. Now, as we know that no real life data set comes without any challenges. So similarly, here is a list of challenges that I faced with this data set. The first one is the mixed data types, numerical, categorical, text, and date time. All of these combination make the analysis really difficult. Then we have the missing values. Example, the product category not always recorded. In such cases, removing those rows was not the effective solution. So we have to deal with missing values carefully. Next, we have the imbalanced labels. Generally, the extreme CSAT scores were less common, so which makes the class imbalance that requires to handle these imbalance labels. Next, we have the short, noisy remarks. This is very critical field as it has the open text formation, so customer can put in any text. So the text data often consider of just a few words. This combination makes it an excellent real-world data set, messy, diverse, and challenging. Exactly the kind of problem deep learning can shine on. So with these many intricacies and complexities, we can't move forward without proper data cleaning and feature engineering. So let's jump on the Jupyter notebook and let me show you how I have proceeded with this step. So here is the Jupyter notebook and the full code that we are going to go through now. So data processing is the stage where most of the effort in machine learning projects lies. For this dataset, I applied several careful data pre-processing steps. So in which the first is missing value. So as we discussed earlier, instead of discarding the rows, I flagged missing data. For example, uh, uh, if item price was missing, I created a binary feature is item price, missing item price. So next, with the proper feature engineering, I derived three features. First is the response delay. That represents the time in R between the issue reported and issue resolved. This captures the responsiveness which we expect to correlate with the satisfaction. Then we have the price binning. That represents the grouping prices into ranging like 0 to 100, 100 to 500, etc. This captures the broad spending segment with reducing the sensitivity to outliers. Next, we have the temporal features. Derived from the timestamp, I extracted day of the week and the hour of the day. For example, issue reported on the weekends may have different satisfaction patterns. Third, feature engineering step was to categorical encoding, in which the low cardinality feature like the agent shift tenure bucket were one hot encoded, and then high cardinality features like the agent name was excluded from the first version since they risk overfitting. Instead, aggregate features like the average CSAT per agent could be explored in future iterations. Then fourth and last one is to clean the customer remarks, or basically the customer remark processing. In short, I cleaned the given text by lowercasing, removing punctuations and stop words, making it ready for further encoding, and finally converted remarks into numerical features using TF-IDF or embedding. For example, the words like delay, refund, bad often points to dissatisfaction, while thank you or great service point to higher scores. So all of the transformation were wrapped into the pipeline, basically the feature engineering pipeline, and saved with the job file. This is important because at prediction time, we need to apply the exact same transformation to the new data as we did during training. So by end of the pre-processing, each interaction recorded was converted into a vector of features that combined structured metadata and semantic signals from the text. Now we have the data engineering pipeline set up. Now let's move ahead and discuss regarding the model building and the model accuracy. So with the features prepared, let's move on the designing the model. The task was formed as a multi-class classification problem, predicting the CSAT scores as the class. So the chosen architecture was an artificial neural network (ANN) because of the several reasons. The first, it can model nonlinear interactions, and second, it easily integrates with text embedding with structured features. Also, it is computationally efficient for the deployment. Now, let me introduce you with the architecture. So here we have the architecture of the model. Yes, so here we have the architecture of the model. So the first layer of the architecture is structured features, which is the plus text embeddings. Now, two to four hidden layers with ReLU activation, and next we have the dropout and L2 regularization to reduce overfitting. Then finally we have the output layer with the softmax activation to produce probabilities for each CSAT class. So that's all about the architecture. Now if I tell you about the training strategy, then first I used optimizer. The optimizer used here is Adam with carefully tuned learning rate. Then I applied learning stopping on validation loss to prevent overfitting. Then I I basically handle the class imbalance using the class weights. So rare CSAT score still influenced learning. Then finally, I used a stratified split to ensure the training validation and the test set had similar class distribution. But I did not stop here. I also explored two more strategies. First, regression, treating CSAT as continuous variable. Now, there was no such results or the no impactful result found in this strategy, but the second one, where I used the ordinal regression to model the ordering exactly, had some impacts. So, but ultimately, I can say classification performed best and aligned with how the business interprets discrete CSAT scores. Now, before the quick tour of the Streamlit interface, let's understand the evaluation and insights. So basically here evaluation was multi-purpose. The first, we used accuracy to measure the overall correctness. Then the micro F1 score to balance performance across all classes. And lastly, mean absolute error to measure average distance between predicted and true scores, treating CSAT as ordinal. The model achieved a strong performance with high accuracy and micro F1. Most errors were minor, predicting 3 were the misclassification. As you can see here, where we have the evaluation, so we must have saved them somewhere in the artifacts. Okay, so as you can see, the confusion matrix confirmed this, showing that uh, uh, error clustered around the adjacent scores. And using SHAP for the interpretability, I identified top drivers of the CSAT. The first is response delay. The longer delays, strong predictions, means lower CSAT. Then, second, we have the customer remarks sentiment. Generally, negative language pushed prediction downwards. Next, we have the third agent tenure and shift. Mostly experienced agents, especially in the morning shift, turned to correlate with the higher satisfaction. These insights provide direct actionable recommendations such as invest in faster response handling and focus training on the shifts or the agent where the dissatisfaction is concentrated. Now, so it's time to walk you through the Streamlit interface. So let me just grab the essential commands and run them to open the interface. Okay, so I'll be taking the command from readme file. Here we have the readme file and here we have the command line that will be used. Also, I was saying that do not worry about some cells that are showing some error. That's just because I was doing some experimentation. That's why you are seeing these errors. So for the time being, let me run the command that will start our app. So just I wanted to open this terminal and let me open another terminal. Here we have, let's load it. Yeah, so we need to run the streamlit run and the name of the our file, which is app.py. Now, upon hitting this URL, we'll be redirecting to the Streamlit page, or we can open these URLs that will also lead us to the same page. Now, as we can see, the app is loading and now it has been loaded. So now let me give you the brief of what component it is representing each fields. So first we have the title of this app, which is CSAT prediction app. Now, as we discussed in the input data points, we have these many important, or we can say the most critical features that influence this CSAT scores. So, first we have the channel name. In the channel name, we could have three options. One, it could be either inbound call or inbound, and second one is out call, and third one it could be email. So we can select one of customer can select one of the options. Next, we have the product query. So it is also a categorical variable wherein we have mentioned the category of the query. It could be related to the product, it could be related to order or returns, cancellation, shopzilla related, payment related, refund related, and so on. It covers almost all the unique categories of the query. Next, we have the subcategory. So subcategory is the derivative of this category. Once a customer selects the category, he can select these subcategories. So all of this data will be getting from the basically web interaction, so you don't have to worry about filling it manually. We'll get the batch of one line of dataset wherein we will be having all of this information prefetched. Now, this is the open field. Customer remarks. Customer's remark can be recorded here. It can be open text, which has a noise, which contains some semantic things. So here we have to carefully clean it before passing to our model, which is done by our data pre-processing pipeline. Next, we have the order ID. Although order ID does not play any significant role in this CSAT prediction, but in order to track the prediction and map it to the main file, we need to keep this order ID. Next, we have the order date. So, order date is generally the current date time, but it can be changed to any date time which is being operated. For example, if the order is placed on 10th October, so I can just put the date over here. Then we have the survey response. So survey response is a similar date time field which can be changed or tweaked based on the requirement. So basically, why this audit time and survey time is important. So the difference between the date this order and the survey will be calculated and treated as a separate feature. Similarly, issue reported at and the issue responded will also be we will be also calculating the difference between these two fields and will be passing to our model as a different feature. So here again we have the date time field which can be choose on the calendar. Here we also have this date time field feature. Now, these three are the product related attributes. Now, basically, these two are the product related attributes. The first one is product category. In case product category is unknown, so we can keep it unknown. Otherwise, we have the predefined categories. We can put one of them. Next, we have the price. Price is an integer format where we accept values up till two decimals. Then we have the connect handling time. So connect handling time is in hours. So for example, if a customer has waited for 24 hours, so in the field of the connect handling time will be 24. Next, we have the tenure bucket. So these two information is related to agent, which belongs to the operational data. So for example, the job tenure of the agent that interacted with the customer could be either less than 90 or greater than 90, or 0 to 30, 31 to 60, or 61 to 90. These binning have been done carefully. These are the not random the ranges. These have been observed from the data available. Then we have the agent shift. So generally we had five shifts. It could be either morning, evening, or sometimes the split of the shifts. For example, agent could have worked half time in the morning and half time in the evening. So that that split of the shifts can also be recorded here. And we have the afternoon shift and the night shift. So this is the all about this interface. Finally, filling out all the values, one can click on the get prediction, the predict CSAT, and we'll be getting here the prediction. For example, let me take one example. For example, we have selected the inbound, and then in the product category we have selected some offers and cashback. Then in this subcategory we have something in, for example, let's take mm, let's take about the online or the technical visit. For example, customer have done some service call, and then he gets the service. And now after that, we got his interaction data from the web. For example, he filled that I love the service. So this is his remarks. So we can put it here. And for the time being, although we can put anything in the order ID, or we can just leave it as it is, it will also work. But for the time being, I have filled this. Now consider the order was taken place on this 9th October, and this survey was responded at suppose 10th October. Only one day delay was there. Then we got about it, for example, on 13th October, and the issue was responded on the same day. Next, the product category, for example, it was some electronics item for which the client has done this service call, and let's suppose the price was somewhere around 20,000. Okay, now the connect handling time was somewhere around, let's say, 5 hours for this use case, and the agent who was dealing was having a great experience and also belongs from the morning shift. Now when we will be clicking on this, our Streamlit app is running, and behind the scene you already know that this all of this fields will be aggregated and pass it to our data pre-processing pipeline, and then our data pre-processing pipeline cleans and process the entire data set, then passes to the model, and then model performs its duty and finally get us the predicted score. So in this case, we are predicting that for this arrangement, the rate will be around somewhere 5. Why this is so? As we can see, this remarks are quite good, and also what we can see, the another thing is agent that is quite experienced, and the morning shift that we also saw in our EDA processes. So I think that's all about this interface. So in summary, DeepCSAT demonstrate how deep learning can enhance e-commerce operations by predicting customer satisfaction automatically. We built a fully automatic pipeline from data, from cleaning the messy data to feature engineering meaningful features and training robust neural network and deploying it in a user-friendly app. The model not only predicts the CSAT with a strong accuracy, but also uncovers actionable insights like the importance of fast responses and experienced agents. This project shows the real world potential of AI, moving beyond academic exercises, solving the business problems, I'll say business critical problems. All code notebook and the app documented in the GitHub repository. You can just go and visit them. And finally, I would love to hear your feedback. Thank you. Thanks for watching.